Welcome back, everyone. Today we're going to look at the fluid pressure and fluid flow lab. In fact, we're going to just do the fluid pressure for now. And so that's what we're going to do today. So how does the pressure vary with depth? We know that as you go deeper, the pressure increases. So if the pressure at the top is P1, as you go deeper, you add rho GH, and that's how the pressure increases. And we want to check this. So we're going to go to this website as usual. You can just copy paste this link or simply go to fet.colorado.edu. I go here, simulations, physics. Um, let's give it a moment. I will just uncheck all of these boxes except for the motion box. I will leave it. And let me just put this one also. Okay, well, it's here, this one. So I click on it and I can download the Java, or I can simply uh, go to the website here and just play it straight on the website. I mean, you can just download the Java version, which I will use. I have downloaded Java, if your Java is up to date, or you can just play it on the browser. Just click on it. It will take a moment. Take a moment. Just give it a second. Almost there. Okay, well, that's what you get. And we're going to use the pressure tab, which is by default what comes up. And you see, it's kind of lower resolution. That's why I downloaded the Java version, and I have it on my computer, so I don't even need the internet. So I have it here. I have exactly the same thing as what's on the website, but look here, the numbers kind of not very clear. I have it's a better version, this one. So I have a ruler here. You can just check the box for a ruler, and I'm going to level it with the surface here. And I'm going to fill this well all the way. Okay, so it's full. And you see here the pressure is 101.3 kilopascals. And we're going to go right to the table here and start fill it up. So it says when H is equal to 0, let's record the pressure. Let's bring it here. When H is equal to 0, we're not deep into the water yet, so we're here. 101.4 kilopascals. So it's 101.4, 101,400 pascals in pascals. So you just because kilo you multiply by 1,000. So I get this. This is the number I will be plotting. And then here it says what's the uncertainty in the pressure? I will show you in a moment. Let's get the second measurement first. It says here, go to a depth of 0.4 meters. Let's see. So this is 1 meter. From here to here is 1 meter. So this dash here is 0.2, 0.4, 0.6, 0.8, and 1. So let's go to 0.4 as well as we can. I'm sorry, no, 0.4 is right here. And yeah, so, but am I sure that I'm exactly at 0.4 meters or 40 centimeters? What's the uncertainty there? I mean, is it here? Is it right here? It's about here, right? But there is still some uncertainty. I think we're off by plus or minus a centimeter. And to be conservative, I would just say plus or minus 2 centimeters. I might be off. And that's why I put the uncertainty in height is 0.02 meters, 2 centimeters, give or take. Maybe, so this is debatable. Some of you might say it's actually 1 centimeter, I think. I estimated, just to be on the safe side, that it's 2 centimeters is the uncertainty. So throughout the table here, 0.02, 0.02, 0.02, this whole thing will be just 0.02. What's the uncertainty in the pressure? Well, let's see, if I move it just ever slightly, it varies by like a decimal here. So 0.1 kilopascals. And so the uncertainty in the pressure is 0.1 kilopascals, which is 100 pascals. And so it will be 100 pascals throughout. Okay? So that is that. Fine. And we just fill out the table here. And it says here, how well do you think we know the depth? So I say, is it to the nearest 2 centimeters? Well, I think I've estimated it, and we said it's about 2 centimeters. And if you disagree with me, feel free to change it to maybe 1 centimeter. Maybe you think it's 5 centimeters is the uncertainty. That's fine. Okay. It could be 5 centimeters. That's actually reasonable too. Um, and now the same thing for the pressure. And we're going to plot at the end, we're going to plot the pressure versus the depth. So this column versus this column. So the pressure will be on the y-axis, the depth will be on the x-axis, and you can imagine what should the y-intercept be, and what would the slope be. So I will leave that for you to explore or experiment with. And that's all I wanted to say. Let's keep this brief, and yeah, so let's explore with it.